All right, everyone. In this video, we are going to learn how to create and solve problems when we have parallel lines that are cut by a transversal. And this particular lesson is going to add to our current knowledge of angle relationships that we learned last week, which last week we learned about supplementary, complementary, and vertical angles. And so when we have a parallel line cut by a transversal, we have a bunch of new relationships that are formed. So we're going to add some more angle relationships to our knowledge. So in this particular activity, we're going to do a little exploration first. And if you look here at our guided notes, you're going to see it says open the following link. So when you open that link, it's going to take you to a website called GeoGebra. And we have already set up for you a little tool that's going to allow you, if you click on point A or point B or point C, it's going to allow you to move these parallel lines in the transversal around, and your job is to look at what happens to all the different angles as you move these around. So I want you to pause the video and just play around with this for a minute or so and just take note of some of the relationships you might see. All right, so I went ahead and I kind of set this particular picture up so we could have some easy numbers to work with. If you look at this particular setup, you'll notice we have a bunch of 120 and 60-degree angles. So what I want us to do is to take these angles and transfer them into our notes so that we can have a particular set of specific angles to look at. And so we had 120 degrees here, 60 degrees, and I'm just going to plot these all around. Feel free to use these exact same angle measures that I'm using because it's going to help us make conclusions about some of the relationships that we see. All right, so what we're going to do is we're going to look at 7 different angle pairs, and we are going to classify them. So we're going to classify them by one of these 7 types here, and then we're going to look and see what type of relationship they have, whether the relationship is that they are congruent, supplementary, or complementary. So our first example, we're going to look at angles 1 and 4, and hopefully when you look at angles 1 and 4, you'll recognize these as our vertical angles. Those were ones we learned about last week. And we know vertical angles are congruent. And we're only going to use these classifications one time. So as we use them, I'm going to cross them out. And so when I look at this picture again for some additional pairs of vertical angles, I have lots to choose from. I'm going to pick angles 6 and 7 as another pair of vertical angles. Okay. So let's look at our next angle pair. Our next angle pair is angle 1 and angle 2. So when you look at these, you'll notice these are definitely not the same. So we know they're not congruent. And when we look at 126 degrees, we see that these are supplementary. And this should remind you of the supplementary relationships we talked about last week. But when you look at the classification, we're actually going to give these pair of angles a new name. So you look at what we have remaining. Hopefully you might see that the best name for these is that they're a linear pair. And we call them a pair because we have a pair of angles. But we call them linear because these particular angles, they form a straight line through here. So you can see these two angles. These two angles next to each other form that straight line. So that is why they are called a linear pair. And there's lots of other linear pairs in this example. In fact, I'm going to name angle 5 and 6 as another linear pair. So let's erase these. Let's go to our next set. The next one tells us to look at angle 1 and angle 5. Now, if I look at angle 1 and angle 5, I can see they're both 120 degrees. So that tells me that their relationship is that they are congruent. And when you look at these particular ones, notice that if I have my 2 parallel lines, okay, cut by the transversal here, they are both, if you look at, we have this little cluster of 5, 6, 7, 8, and a cluster of angles of 1, 2, 3, 4. Angle 1 and 5 are both in the left side, they're on the left side of the transversal, and they're in the top position of each set of parallel lines. And so they're essentially in the same location of each other, and so we call them corresponding angles. So corresponding angles are angles that are in the same relative location. So another example I could pick would be angles 8 and 4. If I look at angles 8 and 4, they are both on the right side of the transversal, right below the set of parallel lines. So let's erase these, and let's move on to our next angle pair. Our next angle pair tells us to look at angles 1 and angle 8. And you'll notice angles 1 and 8, they're both 120 degrees, and so we know that they are congruent. Now let's look at their location. So angle 1 and 8, they're located outside of the parallel lines. Okay, so they're on the outside. So think about what word in our list, forgot to cross off corresponding linear pair. So if we look at the remaining ones we have, if we see that these angles are on the outside, that would indicate to us they're on the exterior of the parallel lines. But notice angle 8 is on the right side of the transversal, and angle 1 is on the left side. So they're on opposite sides. So the best name for angles 1 and 8 is these are alternate exterior angles. And so alternate exterior angles are congruent. And so if I look, the other pair of alternate exterior angles are going to be angles 2 and angle 7. So let's cross those off, and let's erase the angles that we just talked about. All right, let's move on to angles 1 and angle 7. So if you look at angle 1 and angle 7, notice I'm going to give angle 7 two arc marks, whereas angle 1 I'm only going to give 1 because one is 60 degrees and the other is 120. So right there, they're definitely not congruent to each other. 120 and 60 degrees, those add to 180, so these are supplementary. If we look at where they're located in terms of the transversal line and the parallel lines, these are located on the same side of the transversal. But if I look at where they are in regard to the parallel lines, they're on the outside of the parallel lines. So these are called same side exterior angles. So another example of same side exterior angles would be angles 2 and angle 8. All right, let's look at our remaining two. So our remaining two angles, we have our remaining two sets. We have angle 3 and we have angle 6. Now angle 3 and angle 6 are both 60 degrees, so there I can conclude they are congruent to each other. And if I look at where they're located in terms of the transversal line, they're on opposite sides of the transversal. But when I look at where they're at in regards to the parallel lines, notice they're between the parallel lines, or they're on the inside of the parallel lines, which means that these are considered alternate interior angles. They are located between the parallel lines, but on opposite sides of the transversal. So another example of alternate interior angles would be angle 4 and angle 5. So by default, since we only have one angle type left, let's go ahead and talk it out. We have angles 3 and angle 5. And I'll notice that one is 60 degrees and the other is 120, so we know they're not congruent. 60 and 120 add to 180, so we know these are supplementary. And so the reason why, and so let's talk about what they're called. If you look at where they are in regards to the transversal, they're on the same side as the transversal, and they're located between the parallel lines. So we would consider these same side interior angles. And so another pair of same side interior angles would be angles 4 and angle 6. So those are our 7 angle types. 2 of them we already knew, vertical and linear pair, which we had never used the term linear pair until today. They're just a type of supplementary angles. And then we have 5 new angle relationships that are created by those parallel lines. Now, you'll also notice when it comes to our relationships, we use congruent and supplementary, but we didn't use complementary. So the last question, and I'm going to let you think about this, and then you can check and see what the answer, if the answer you came up with kind of matches my answer, but when or would a complementary relationship exist? So I want you to think about that. See if you can come up with a justification as to when a complementary relationship would exist, or would they never exist in relation to two parallel lines cut by a transversal.